we have an app called Configure Printer. So I don't know how the organization really configure printer, but before the system was there, the way we configure our printers is basically we raise a ticket with our operation teams, and they basically come and do some magic and they say you're installed, right? You go to a different location and you have to call that number again, they'll come back and say, you know what, I am busy, you come back late. So what we have done is we have basically rolled out an application to configure system. So to whichever location you go, you basically click that button, it identifies your network location and the printer closest to you, and it automatically configures it, right? So good, great, right? Now printer can be configured in 2 minutes, and that's the feedback that it states that printer can be configured in 2 minutes, right? But this is the interesting part about configure printer, right? So the printer is configured, but there is no paper. Right? So this is not system's fault, but at the end of the day, it is not meeting the job that the end user is trying to do. So this is how this feedback loop helps, right? And this is one of the other examples, right? Again, this is no fault of the system, but there is an application that's for commute or cab booking, right? But this is the associate. This is what the associates experience with using that app. The app works, but it is like the operation is success, patient has died, right? So the cab had reached on time, and she got the cab, but eventually it took 2 hours for her to reach the office instead of 15-20 minutes, right? Absolutely no traffic, nothing, because he was doing all the other pickups. But how do we get these kinds of feedback back to the process owners and app owners? So we have seen this closing the feedback loop is very important, or else we would have been very, very happy just saying that, oh, printer can be configured in 2 minutes, right? The cab has reached on time. He would have said that I have reached that location exactly 2:30 that I'm supposed to reach. But he has reached around 2:30, but it doesn't delay the user that he is supposed to delay, right? Yes, the printer is configured, but it doesn't delay the user because anyway the user cannot do a printout of it, right? And that's a qualitative view of our application, and this is a quantitative view of our application. Again, this is one of the applications in store which gives a quantitative perspective of the application, right? It shows out of those, there is an application called Circles that's basically for updating profile, and I would like to show that application. Unfortunately, if I click on it again, I have to do a login of this because of session timeout and other things. So out of those 160,000 users, about 130,000 users have used this application, right? This application has got a launch count of 1.3 million, right? And it also shows what are the various top departments that are using this application and what is the source that this application is getting launched from, right? Are they directly launching it? Are there any email that link has been sent? Are they searching and all these things? So that when they build the next iteration of the application, they can take into account of all these various triggers and enhance that or do whatever they want to do, right? And it also talks about what is the overall stickiness to the application from the end users. Are they coming once and they're dropping out? Are they consistently coming back again and again, right? If they're coming once and they're dropping out, which means there is a serious problem, right? They have to go back and fix in the next item, right? So good. Now we can develop the app faster and we can gamify it. But it had opened a whole lot of problems, right? Now what we have in store is 1,000 apps across the store, right? Now we have changed the culture to release it faster, or we have set in a way that the developers need not or cannot think it as a big monolithical application, that we have changed the culture. Now we have opened a whole lot of problems, that's operations problem, right? We have 1,000 apps in store, and this 1,000 apps roughly translate to 5,000 or 6,000 components. There is web application, there is web service to it, there is database components to it, there are batch processing components to it, right? And there are about 1,000 developers, 1,000 odd developers across the company develops apps for all these things, right? And we manage 10 different environments. There is dev, there is SIT, there is production, there is UAT, and also the students are getting recruited every year, right? So they also get to use this platform even before they come into this. They experience what an enterprise application development looks like, right? So we have about we have students environments also where the students from the across they can come and build apps, enterprise apps, right? And we have about 650 plus TFS projects alone, right? And there are about 120 servers host all these applications, across, host all these 10 different environments and all those 1,000 apps, right? And to make it a little more interesting, we have developers across geographies. There are developers working from China and there are developers working from US, right? We cannot say no to them. You know what? Our operation teams is in India. You can develop or deploy application only during our working hours, right? We cannot say that. That's simply not acceptable, right? And to make it interesting, we have a private cloud. Completely all these things are hosted on the private cloud during a promotional event or something. When the mail goes out, we all know that there will be a spike in usage, right? So who will want to see whether he or she has not promoted or not, and the persons that he is interested in got promoted or not. So we have an app for that also, and typically during those times, we basically scale out the infrastructure, right? For 2 or 3 or 4 days, we basically scale out that infrastructure, and post that we basically shrink it and back it to the level of 150 basic or 120 servers, right? And we have lots of challenges in moving the application from environment to environment, or even to get it onto one environment. Because it's a shared environment, we cannot, unlike before 2 years back, it was all one big monolithic application. The developers have direct access to the production system and they can go do whatever they want. They go break it very often, and it is what. After we moved to a shared model and posted our private cloud model, this is how the process, our deployment process was, right? It was a 10-pager document, right? So we want to slow down the speed that they are developing. Basically, we said, go fill this 10-pager and come back. You know what? Next 2 days they will not come back. So we were very happy, right? And raise a ticket, and even after 2 days, if they come back, you know what? Now you cannot directly send the document. You have to raise a ticket. Only then we will accept, because you know emails, right? Email get lost and all these things, right? Okay, now you have raised the ticket. Now there are 10 other applications in the queue. You go back, wait in the queue, right? And this operation or this deployment guide has got 15 different steps, right? From creation of folder all the way to copying the code and setting up the security and all these things. Now good, your application is deployed, go test it. For whatever reason, right? Either one of the steps is missed in the document, or one of the steps that mentioned in the document is missed by this operation person. If it is not working, they have to go back on the queue, right? And this was the kind of experiences that we were facing, right? I wouldn't call these as challenges. This is actually a frustration. I am part of the operation team. We used to have a 5-member team, and whenever any application goes to production, we all will sit back at the office. We know for sure it will break, right? Like I anticipated and brought some chocolates. I anticipate there also and sit at office and ensure that it is supported and it's successfully deployed, right? And the developers come back and say, you know, the exact code that I deployed in SIT, I have deployed in Dev, it was working. But for whatever reason that it is not working in Dev or SIT, right? You have some environment problems. How many of us have faced such kind of scenarios? Wow, right? All of us. This is what's actually happening, right? There is absolutely no code change. I've completely done my development and unit testing was fully complete. Now I move the same code to a different environment, it breaks, right? And there were always environment issues. So this is what it took us to deploy, right? So we had about 12 servers for production. In the production farm, we have about 12 servers, right? So it takes, sometimes it goes up to 15 servers, and every server to deploy, it takes about 20 minutes for us. Right? Because we have to log in into the server, we have to deploy the code, we have to do the IES reset, we have to do blah, 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 15 different steps, right? And today we are deploying about 600 on an average, and some days it goes up to, 650 deployments, right? And if we have to translate it to the persons that's required, we would require 7 persons, and basically it requires 3,000 minutes to basically deploy all these 600 deployments that we got, right? And eventually it is definitely not a possible thing. So what we were almost saying is, you know what, you cannot develop it so fast. You have to slow down your development, right? But again, that is not acceptable. But that's not the reason that platform has set for the core cultural shift as was planned, right? So what we have done is we have done automation, right? The deployment happens in a single click. And it is just not a deployment artifact, it is a complete deployment orchestration. It happens. When they deploy the code, it automatically puts the right set of configurations that it has to put, right? And it basically does all kinds of performance enhancement. I'll just talk about that in a minute. And it ensures that code is synchronized across all the machines. Even though we add and remove VMs based on the need because of the cloud-based infrastructure, right? It basically does the synchronization across all the machines, and it ensures that it is intact, right? The code is intact in all the machines, right? And on top of it, it runs a certain code quality tools, right? So there are so many deployments happening, right? How do we ensure that the things get deployed is of certain quality? So we have integrated that with code quality tools, and if one of those fails, it will not allow the developers to deploy, right? And so now that it is all automated, so how does it matter who clicks on a button? So what we did is, we have basically translated this and given this experience to developers, the deployment experience to developers. Now we allow the developers themselves go ahead and deploy, right? And what we have seen is, now we don't need an operation person who takes care of those 10 or 15 pager deployment guide and run through it. All those workflow approvals required based on the performance testing, we basically mandate two kinds of testing, right? One is the integration testing, which is certified by our testing team. They have some automation test suites and all these things. And another thing is the PACE team or the performance team, right? Because for us, performance is the #1 requirement. If it is not there, you're not allowed to deploy. So all those workflows are completely automated, right? So they go deploy the code into our QA environment. It automatically generates a label, and that label is visible to our testing team and the performance testing team. Basically, they go ahead and give the sign-off from those two teams, and once it's signed off, which means they're good to go, right? Again, for the kind of the code, the number of lines of code that getting churned every single day, it is very difficult for someone to basically go ahead and do a manual code review. So we have integrated all those industry standard, the Sonar, right? I'm not sure how many of you heard about Sonar, right? We have integrated a Sonar as part of our deployment process. As soon as you go ahead and deploy, it will come back and tell you what is the quality of the code that you're deploying. If it is not of acceptable quality, it will not allow you to deploy. Okay? So what we essentially did is, eventually all this workflow is built, right? We basically allowed developers to deploy onto production. So end of the day, it doesn't matter who clicks on a button, it's basically click of a button, right? All those creation of virtual directories, setting up of security, copying the code, compiling the code, and every single thing is automated. And the complete workflow is in place. Previously, we used to track all those sign-offs via email. Now, even those are being automated, and we ensure that only the signed-off code and the code quality moves to production. Basically, what we did is we allowed the developer to deploy even onto production on their own. Okay, so how many of you have seen this book of Speed, right? So if not, you should read this book by Stoyan Stefano. Sorry about my bad pronunciation, right? He talks about performance engineering. Performance engineering is again a much bigger topic. We will scope it to what is our interest to this thing, right? And you should go ahead and read this book. And this is, if you are a performance engineer or even a developer, right? You should be very well aware of all these things that's given over there, right? We all know this, right? When someone clicks on an application or a web page, the request goes back to the server. Server does the processing, and it returns the result, and the response travels via our network, and it gets rendered on the browser. This is all we know, right? So what Stoyan says is, no matter how much performance we do at the server side, right? Okay, before that. So when we talk about optimizing the performance to a developer, the first thing that comes to my mind is either I will tune some of my Java or C# or whatever language that I'm working on, or I tune my scripts, right? So, but what he says is no matter what you do at the server side, you are optimizing only 20% of it. And rest 80% are traversing over the wire and getting rendered on the browser. So if we say this to developer, he will say, those are out of my control, right? Network and the end user client is out of developer's control. How can he do anything about it, right? But essentially, this is what getting traversed over the wire. There are a bunch of HTML files, there are a bunch of JavaScripts and other things, right? Now JavaScript has become a first-class citizen for development. There are lots of JavaScript files and lots of requests that's going, right? Just think about this, right? We all know what is minification, right? Minification is like our zipping concept. When we zip a Word document and send it over the wire, we know the size of it gets reduced and it can be transferred faster, right? And the same principles can be applied for CSS and JavaScript also. So why not minify it and send it, right? Similarly, bundling. So if there are 5 or 6 different JavaScript files there, why each of it has to go, each of the requests has to go separately to the server? Why not bundle it optimally and send it, right? So that, and we all know what is data URI, right? Certain images that can be, now it is again not applicable to every image of every size. Those images that is of certain size and that's of certain nature can be directly embedded as part of the HTML so that it cuts down the number of calls that goes to the server, right? So we have about 1,000 developers going and talking every single thing to all the developers was a major challenge, right? Again, we are a platform team and one of our job is to basically do most of the things so that a developer need not do. So what we have done is we have basically automated it. And all these things, when the code is getting deployed, it's just not the code gets deployed and the code quality tool runs, it also runs all these performance engineering aspect on its code and ensure that the code is deployed successfully even before the code is getting successfully deployed, right? So if you see this, nothing gets changed on the server. So for the developer, it is still saying the code is intact, whatever that he has taken in the source control is completely there. But over the wire, when it gets deployed, all these performance engineering aspects are done on behalf of the developer, right? So without developer doing any single thing, all these things are done at the various different layers so that the application becomes faster, right? Configuration. This is very dear and near to me. So tell me how many of you have faced the application downtime because of wrong configuration, right? This is disastrous, right? So we all say config and what a big deal about config, right? So I am coming from the operation teams. 20%, one of the very common mistakes for developers is basically because of wrong configuration, right? They basically fail to update the connection string or one of those config settings that they are supposed to do. So when we look into it, basically 20% of our tickets that we got is because of those wrong connection or wrong config entries, right? And a couple of months ago, one of the application was down, critical application was down, one of the business critical application was down for 2 days just because they had a wrong config entry, right? It is not one of the places that we usually suspect because we assume that it will all be fine and something fails, we never suspect configuration, right? But that is happening over and over and happening again and again. So what we have done is we have completely automated all those configuration settings, right? So when they deploy, it just not deploys code, it runs the code quality tools and ensures the code that gets onto production is of certain predictable quality and all the engineering aspects are applied on top of it. It also ensures that right configurations are there, right? We know if it goes to, again, this is a platform-based approach. When the app goes to production, we know what is the database server that it is supposed to refer to and what is the database server in QA that it is supposed to refer to, right? So basically, systems identify that he is going to deploy on this environment and this is the server that he is supposed to use and it automatically does all those changes that he wants to do, right? And there are certain cases that where they have to use those specific, right? For instance, the services are, there are so many web services get developed and we will not know all those web services where it's posted and all these things. Basically what we have done is we have put a validation on top of it, automated and put a validation on top of it. If it is not the right set of configuration that you are supposed to deploy, it will stop the developer from doing it, right? So now we can pretty confidently say that there are, again, we cannot do say it 100%, but 98, 99%, if there is something goes wrong, it will not because of the wrong configuration, right? So I was mentioning that we are allowing developers to deploy onto production, right? Now we have become really brave, right? Operation teams, once where we used to sit at the night every time the application goes to production, now we have reached to the level of where we allow the developers to deploy onto production. And this is how we can ensure that the code that goes to production is off, or it will not break, right? So it's basically the application has to meet the 500 millisecond response time. If not, your application is not going. So first thing is taking care of the application that goes is usable because it is performant. And lots of performance boosters on top of those response is getting added or getting automatically changed on behalf of the user. And third thing is the code that gets into production is of a predictable quality. Right, and those things, most of it is designed in such a way that those applications are independent of each other. And however, there are several scenarios where they are dependent of each other. Either they are consuming this service or they are using that database, so on and so forth. Right. So for those kinds of things, we have well coordinated releases across the teams. And previously Matthew was mentioning about the operability, and one of the things that is important for our mission critical application, again this is not for all applications, for the mission critical application is we call it as health API, right? So basically what this health API is, it's basically a monitoring service, right? So monitoring, some of those industry standard monitoring tools can do either the server or the infrastructure and other things. It actually will not know what is running in the code, right? Because the developers write it and only developers know what it is. So we have mandated health API to be built as part of that system so that it is operable, right? And we constantly keep monitoring all those the server infrastructure and all these things. The application health API gives what is the health of the applications from the code perspective. It is just not the infrastructure. We also ensure the code is running and it is operable, right? And before moving the next iteration onto production, it's basically we ensure that the previous cycles exceptions are triaged and fixed before, at least all the P1 related bugs are fixed before it moves to production, right? In spite of all these things, what we have seen is we basically see there are always issues, right? They always say, you know what, I have done my code. If it breaks, it is system's problem. I don't know what happened, right? My code was working at my end. Only after I deployed over there, it failed. So it is not my problem. So what we have done is to bring in this culture. We basically said, okay, it's a pain for us. You also face the pain, right? It's pain for the operation team. The development team should also face the pain, right? So when it goes good, all the credit that development team takes care, right? So when it is pain, why should operation teams take a pain? So what we have done is we have basically modeled our team like this. It's basically all these teams are there, and within each team we have put an operation team, right? So that they just don't take credit. When it goes wrong, they go and fix it also, right? And we have something called as test ops, and that's one of the other things that's catching up in the industry. Probably you can find it out offline yourself, right? And one of the things that we rigorously track is scorecard. Again, this is something that I have made it. This is not the real scorecard, but these are all the various metrics that we track all the applications on, right? So many a times they fail to perform the unit test, right? They want to move it so fast, they don't do the unit test, right? And what is the time that issue has been reported and how quick they are able to resolve the issue, right? And what is the adherence to the code quality, some of those code quality tools that we have integrated. And what is the release frequency, and how many exceptions has been logged in the previous release, and what is their overall rate, right? And it gets bubbled up all the way up to the leadership team, and it reflects their team, right? If the overall score says their portfolio is good or not, right? If it is not good, obviously it reflects on the leader. So ensure that the operation persons that's as a part of their team gets his goal is to basically ensure that he has to go green across all these metrics on scorecard. So this is how we rigorously ensures that the tighter integration between the development team and the operation. So with all these things, this is what we do today, right? So till date about 2.26K deployments have been done, and every single day it takes about 650 deployments across all those 120 servers. It's just not in specific machine. It is across our one environment, across all environments, across all those 120 servers. There are about 650 deployments happen every single day. And we have certain, and again, even though the deployment is done by the development team itself, we have given only to the operation persons of the development team to go ahead and deploy the code. There are about 495 people who can deploy the code. Right? And there are about 13 different environments that we support today with all those automation and the teams that we have done, except the infrastructure layer, including all the application database and all these things, we just manage with 2 operations person. And which is again of SOX complaint. SOX was one of the perennial problems that we were facing because they have lots of rules. Now that we have automated, we can exactly predict that whatever controls that has been set, it's applicable for those applications that's in SOC. Every time the auditor come back and say, yes, this control in place, basically the person who develops cannot go ahead and deploy the code. Right? It has to be released by release management. So all those SOX related. And Cognizant is our internal quality program, and all those applications that gets released is of Cognizant components also. Right? And so are we following DevOps in true spirits? Right? This is the result that we have now. So I just leave it up to you. Okay. Okay, so what it is it talks about release early and release often. We have about 433 apps, right? And when we do a release early and release often, even within a single app, it is getting released multiple times, right? And in a day, we do about 650, when we talk about this automation, the culture part, yes, we release early and release often. In terms of automation, we do about 650 deployments on average. It's increasing as the number of application increases. And we have, yesterday we are measuring this, and it was about 10 GB of file that gets transferred across all these 120 servers, right? And it is about 100, close to 200K files that's getting deployed, right? And in terms of quantitative, in terms of measurement, we do it quantitatively, we do qualitatively, and we do the FMEA approach, right? Failure mode effect analysis. So this is one of the industry, very old industry. Again, it is not a specific to IT industry. It actually came from manufacturing for a consistent way of analyzing and fixing the problem. So we use failure mode effect analysis, or it's called as FMEA, to ensure that those issues that's pertaining are taken seriously and it's fixed. And in terms of sharing, this is what we basically do. We basically put a team structure which is of development and operation team very integrated together. And we also, how to ensure that they are very effective, we put a scorecard, and all those logs and other exceptions, it just doesn't stop with the operation team. It basically goes to the development team, and the operation persons within the development team ensure that they are fixed. And these are some of the awards that one Cognizant program has won. And we are very humbled to take this, right? And this is the mention about one Cognizant by Jeffrey Moore. Jeffrey Moore is one of the renowned industry expert in terms of systems of engagement, and this is what he has told about one Cognizant, right? And this is the award that one Cognizant has won for this management, right? And hope I'm not taken much of your time, or I've not hold you long back from lunch. And this is what we done. And thank you very much. Right? And this is my mobile number. You can feel free to reach out. Right? And if you have a minute, I just quickly want to show you one very simple thing. Right? Our deployment experience for users. Right? Deployment, obviously it will take more time, so I took the HTML prototype of exactly the same, and this is how it looks. Right? So he get to choose the application that he wants to deploy, and he drags and drops to the environment that they want to deploy. Rest all are configured at the back end, and it's taken care for the developers. And once it's completed, they can go ahead and view the log. Good? Thank you.
Do we have any questions?
It's really an impressive thing, certainly.
I want to understand what are these apps? I mean, you mentioned that several, huge number of apps are deployed every day. These are apps for internal use, or these are also apps that go out from the CTS as a, as a product?
These are apps for internal business need for it, right? So previously, if we have to do a HR process, probably it's one big monolithic application that's sitting. So probably if we take about HR process, now it is translated to 10 or 15 apps, right? Again, I don't have a time. So what we have basically done is there are 10 different apps. Think about all these advantages that comes along with it, right? The first thing is it can be developed faster, right? The teams can be split and they can work in parallel. So, and you don't need a big architect